So when we talk about solving an equation for x, my first question is, what does that mean? When you see the word solve at the beginning of a problem like this, what is it really asking you to do? Get x alone. So the word solve often takes on a generic connotation when we think about problem solving. Oh, problem solving. Solve means find an answer. Well, be more specific in your brain than that, because your algebra professor is more specific than that. When they say the word solve, when your textbook says the word solve, when any other math professor says the word solve has a specific meaning, and it is just that. Always means get x alone, or get whatever is the variable that you're solving for alone. Get x alone. In other words, from a mechanical standpoint in these problems, we need to do something to each of these equations so that the variable x is by itself on one side of the equation, and on the other side of the equation is a number. Right. We're going to bend that a little bit when we talk about some more stuff on Wednesday, when there's more than one variable in an equation. We're solving for one in terms of the other. But for now, x is the only variable, which means if we get it alone on only one side of the equation, then the other side of the equation must be a number. And that's how you know you're done. Don't lose sight of that goal. You should make sure that every step that you take in solving an equation is getting you closer to that goal. And different equations of different levels of complexity, there might be more to do in order to accomplish that than others, and we'll see some of that range in these three examples. So let's start with example A. Negative 4x equals 24. What step do you want to do to get the x alone in that equation? What did you do to solve equation A? Divide by negative 4. So, first of all, tell me why you chose to divide.
Because it's multiplied by x.
Yeah, what's multiplied by x?
Negative 4.
Yeah. So you looked at this equation and you said, what is it that's preventing x from being by itself on the left-hand side? Well, it's got this negative 4 attached to it. If we can somehow just get rid of that, then x will be alone and we'll be done. But getting rid of it requires us to look at how it's attached. How is it connected to the x? What operation of arithmetic connects negative 4 to x in that expression? And you just said what it was. What really is secretly in between the negative 4 and the x there? What operation? Multiplication. Anytime there is a number next to a variable without an operator in between, multiplication is what's implied there. That's how algebra uses notation. So negative 4 multiplies x. So if I want to get the x by itself, I have to reverse that. I have to undo that. I have to divide. If negative 4 is multiplied by x, to get the x by itself, I have to undo by dividing by negative 4. Before we go forward, did anybody else start this problem differently? Everybody divided by negative 4? Anybody try something different? Common mistake is to not see the negative sign out in the front and to divide by 4 instead of by negative 4. Which will help us get the x by itself, but it doesn't address the presence of that negative sign. So dividing by negative 4 will take care of the negative sign and the 4 all at once, which is nice. It's one step, and it gets us to where we're going. So I think we can agree that dividing negative 4x by negative 4 will leave us with what? Just x, which after all is what we wanted. That's why we're dividing by negative 4. It undoes the multiplication by negative 4 that's attached to the x. But if I divide by negative 4, what else do I also have to do? Yeah, exactly. So this is one of the guiding principles of algebra that makes equations work the way that they do. Similar to how we had to talk about fractions. When we talked last week about fractions, we said, whatever you do to one part of the fraction, you also have to do to the other part of the fraction. We were talking specifically about multiplication and division in that case, but that's because of the balance that a fraction implies, that the numerator and denominator have to stand in the same ratio before you do something as they do after you did that something, right? And that balance has to be preserved, otherwise the value of that fraction changes. The same principle applies to equations. An equation is fundamentally a statement about balance. It tells us that whatever quantity appears on the left-hand side of that equal sign and whatever quantity appears on the right-hand side of that equal sign have to be the same number. They have to be exactly the same thing. Otherwise, the equation is not true. The equation is a falsehood. And so if I begin my life with an equation like negative 4x equals 24, and then I do something to one side of that equation, you got to do it to the other. Otherwise, the equation is out of balance, where it's not guaranteed to still be a true statement anymore. In other words, it's not guaranteed to tell us the same thing about x that the original equation did. And after all, what we're trying to do in this whole process is discern the value of x from the information that we were given to us at the beginning of the problem. So, whatever we do to one side of an equation with algebra, we must do exactly the same thing to the other side. So divide the 24 by negative 4 as well. And that's the key to what makes this whole enterprise of solving an equation work. As long as you do the same exact thing to the left side as you do to the right side, you have not done anything wrong. Now, you might not have taken the most efficient choice towards simplifying the equation. We might, see some examples in a little bit. But you're guaranteed to still have a true equation, still have something which characterizes x in the same way as the original, as long as you do the same thing to both sides. And when I say thing, I mean an operation of arithmetic: addition, subtraction, multiplication, or division. What's 24 divided by negative 4? Negative 6. And at that point, we've solved our first equation. One of the other great things about equations is because it's so easy to tell whether an equation is true or false, anytime you solve an equation, there's an easy way to make sure that your answer is not wrong. How can I make sure that x equals negative 6 is not a wrong answer?
Substituting it in.
Put it back into the original equation. That will always tell us. It might not tell us whether we've gotten all possible solutions, but it will at least tell us that we got a solution that works. If we plug it back into the original equation, and what do we hope happens? What are we looking for after we plug it back into the original equation? Yeah, what we should see is that both sides of that original equation are the same number after plugging in x equals negative 6. That's your check. One of the best things you can do for yourself in any mathematics class is not to rely on your professor or your pal to tell you whether one of your answers is right or wrong. If you can figure out how to tell for yourself whether one of your answers is right or wrong, you completely cut us out of the process, which is great. That's what we want you to do. Because when it's just you and a test sitting in front of you, you can't come and ask me, hey, is this answer right? If you can figure that out for yourself, dynamite. Your score goes up 20 points right away, just right off the top, if you have the ability to check your own answers and you take the time to do it during an exam. So coming up with these little checks is so valuable. And if you get into the habit of doing it, it really will improve your life in any math course. So to check my answer, I'm just going to put the empty set of parentheses where there used to be an x, and then follow the guidance of the value of x that we just discovered, x equals negative 6, to just plug a negative 6 into those parentheses. Well, what is negative 4 times negative 6? Negative times a negative gives me a positive 24 on the left-hand side of the equation. I have a positive 24 on the right-hand side of the equation, so what do we conclude about our answer? X equals negative 6 is a solution of that original equation. Again, this doesn't tell us that it's the only solution. It is. But at least if we had gotten something that didn't match up right here, we would know that we did something wrong and we should go back and look at our work. It's better that you catch that on a test than I catch that after the fact.